Sophie, and once again this is my assistant Adam. Today our teaching and learning episode will be focused upon the phases of matter, and we will be exploring the way solids, liquids and gases change under different situations such as heating and cooling. The teaching and learning episode will be directed at a Year 5 level, which will mean that we'll be using language that is friendly to this age group. How does that sound, Adam? Are you ready?
Yep, I'm ready.
Brilliant. Let me first ask you what you believe I mean when I say the phases of matter. Okay, I can see that you're a little confused by my question, so I'll ask you in a different way. Do you know what the three main ways we see matter formulated in are?
Solids, liquids and gases.
Perfect. That's correct. Solids, liquids and gases. There is also a fourth one that we usually don't hear about called plasma, although today we will not be talking about it. Tell me what you know about solids, liquids and gases.
Solids are hard and don't move. Liquids can move freely and be poured, and gases are like air.
Okay, so you think that solids are hard and rigid. You believe that liquids are things like water that can move freely and be poured, and gases are hot air. Is that correct?
Yep.
Okay. And what do you think each of these states of matter is made up of?
They're made up of different things depending upon what type of matter they are. Like things that make up a liquid are different to a solid.
Oh, okay. So you think that all of the substances at each change in phases of matter are different?
Yeah.
I'm going to explain to you why the substances are all the same, and then in our experimental inquiry, hopefully we see some results that back me up. Have you ever heard the words atoms or molecules before?
Yeah, I have in science class.
Fantastic. Remember that atoms are the building blocks of life and make up every single substance or thing on planet Earth.
But when the changes are happening, the solids, liquids and gases look completely different, so there must be different things.
I like your thinking, Adam. Yes, they do look completely different, but the atoms are actually undergoing a physical change, not a chemical change. Physical changes do not result in a change in the chemical composition of the substances involved. Physical changes are generally reversible and are centered around what we call the particle theory, which involves atoms, molecules, energy and movement. Have you heard of the particle theory before, Adam?
Yes.
Have you done a little bit of that?
Yeah.
Okay, brilliant. I'm glad to know that you remember some information that you've been previously taught. So to explain the particle theory in more depth, it is how close the atoms are together and how much they move around, which determines the states of matter. So all of these atoms in each state are moving. So the atoms in this fork are moving, although it's still a solid.
They couldn't be moving that much though, because I cannot feel it.
That's right, Adam. So for a solid, the atoms only move ever so slightly. So it's so they stay hard and compact. How do you think atoms move in a liquid?
Yeah, they'd be moving around.
Yes, they would be moving, and they would be moving with different amounts of kinetic energy than those atoms of a solid, wouldn't they? Do you think that they would be moving more or less than in a solid?
Probably more.
Now that we know that atoms move more freely in a liquid than in a solid, how do you think they would move in a gas?
Super fast.
Okay, I agree with you that gas molecules and atoms are moving a lot faster and more freely apart than those in a solid or a liquid. What physical changes occur through the changes of matter? Use water as an example for me.
The ice is the solid stage, and it is hard and rigid with the atoms close together. In a liquid, the ice would be water and the particles would be more free. In a gas, the water turns into air and goes and mixes with the other air.
Actually, Adam, in a gas, the water evaporates and continues to be water molecules in the air which we cannot see. How do you think these physical changes would occur?
Heating or cooling?
Perfect. How do you think that increased or decreased temperature would affect the matter and their atoms?
The heat makes the particles move apart, and because liquid is, it was ice, and if it was a solid it would be cool and become solid ice. I guess in gases the liquids could be heated a lot and it would turn into evaporation into the air like a kettle.
Perfect. heated, the increased kinetic energy allows the particles at the surface to escape into a gaseous state, which means the atoms are moving a lot faster. Alright, I feel as though we have the knowledge to create an experiment to disprove some misconceptions that we have. Before we start our experiment, we have to create an inquiry question. What do you think would be a good inquiry question about temperature and the states of matter?
What about how does the temperature affect the weight of different objects across the different phases of matter?
I absolutely love that question, Adam. Now to create an experiment. I've come up with an experiment which tests the weight of the materials at each stage of their matter and what temperatures they have to be to transform to a different state. Do you think that this would answer our inquiry question?
Yep.
Okay. So in this experiment, we'll be using heat from the stove here. So we'll be wearing our aprons and some safety gloves, but I think that we should also come up with some safety rules to ensure that nothing happens.
Yeah, keep our hands away unless we're asked to touch. Don't be silly, and make sure we know where all the objects are at all times.
Perfect. So for this experiment, I've selected a range of materials that we will be heating on the stove to observe their changes of matter. As we see the change occur, we will be taking pictures and taking the temperature of each substance. This will show us what temperature the states of matter change for different substances. Let's check that we have all of our materials. So I'll get you to move over here. So do we have water over ice?
Yep.
Milk, which is frozen?
Yep.
Chocolate?
Yes.
Candle wax?
Yep.
Thermometer?
Yes.
Scales?
What are the scales for?
So we're going to weigh each of the substances as their matter changes to see if there's any differences in their weight as the changes occur. Do we have the scale? We've got the scales. What about the pot?
Pot? Yes.
Yes? And we've obviously got the stove. So it's time to start our experiment, so we're going to put our gloves on now. Alright, so first of all, we're going to put the ice into our pot. And we're going to weigh how much that comes out to be. And you tell us that.
100 grams.
Okay, so we've already taken the pot's measurement prior to the experiment, so we'll take away how much the pot weighs from that to find out how much our ice cube weighs. Next, we're going to take the temperature. So I'll get you to grab the thermometer. You can take your gloves off for this because we aren't using heat yet. And put the temperature in. Okay, so there it says 1 degree. So it's already at 1 degree because it has already started melting. The next thing we're going to do is we're going to put our gloves on and move our pot across to the stove. Perfect. And we'll turn that on. And the following bits of our experiment will be that as this melts, when it's fully melted, we will take a temperature reading and we'll take a scale reading. We'll record both of those and take a photograph. The next thing that we'll do is we'll pop the lid back on and we'll heat it up really high for a total of 10 minutes. Because at 10 minutes, we'll then put the temperature thermometer back in and we'll work out the temperature that it is, and we'll weigh it once again to find out how much gas has been created by taking away what our original solid weight was from the weight that we have now, and that'll give us how much gas was created. So from there, we'll do that with the remaining materials here that we have, and we'll compare our results at the end to see how the temperature affects the weight of the substances and the way that they change through their states. Thanks for your help, Adam.
That's all right.